Hey, Algebra 1, Mr. Catlin here with your lesson on residuals, kind of going over that with your cool down here. Each of these graphs that we see below are graphs of residuals from the same set of data using different lines to fit the data. Okay, so it's from the same data, but we use different lines. Which graph is most likely to represent the residuals from the best fit line? So we're looking for the line that fits our data the best. And we should be able to see that from the residuals. Okay. So the residuals are showing how far the actual dots are from our line of best fit. So, like, for example, if we had a graph of data and we had dots all over the place, okay, and we draw a line of best fit, the residuals are essentially going to tell us how far each of those are from the line, right? So all of these distances that these dots are from the x-axis is showing us how far the actual values are from our estimated ones from the graph. Okay, so as we go through this and pick the one that we think is the best fit line, we need to keep that in mind. Well, two of them jump off as being not very good options because we have dots that are far away from the x-axis. Like, for example, C, it's got these which are without, out of the range of even being within one, like in the 1.5 and 2 range. And then D has that similar on the same side below it. All right, down here at like negative 1.5 and 2, negative 2, that's how far those dots are away from the line of best fit on our graph of our data. So C and D don't jump out to me as being good choices, but a lot of students are going to pick C and D because they feel like it creates a line. And that's not what this question is asking. This question is not asking which one. That was the question yesterday. The question yesterday was which one of these graphs, would be modeled by a linear function. That's not what this question is about. The linear function is already representing one of the graphs. We are picking the residual graph that shows that it was a good line, that it was close to the line. The dots were close to it. And these do not have close dots. Now, these two on the top are pretty darn close. They're both within one, I would say, except for the B. It has a couple of residuals that are out of the range of being within one away from the line. So that's why I'm leaning toward A for a couple of different reasons. First of all of the dots are within one range from the x-axis. That's a good point. And the other thing is the dots are on top and below instead of just all below. That makes me think that this line is all below our dots, or where this one has dots above it and dots below it. So it seems to be more centered, you know. So what I would do for this one is I would select A and I would explain my reasoning again, like I just talked about. You can listen to my explanation that I just voiced. But if you don't explain, you're not going to get full credit on why A is the best choice for the line of best fit in this particular case. See you guys.